Today we're going to look at how we use molarity as a conversion factor, okay, in our stoichiometry problems. Okay, so if we've not talked about molarity before, molarity is about the concentration of chemical in a solution. It's about how much of it is there, like how tightly packed we've managed to get that chemical. Okay, the better way to look at it for us, for our purposes, is that it is the moles of that chemical per liter of that solution. So it's not necessarily moles of the chemical per liter of the water that we added to it, but like the whole solution. So if I have a solution that has 1 mole in 1 liter, I can then take 1/10 of that liter, or 100 milliliters, and know that I have 1/10 of a mole. Okay. We use the unit M that stands for molarity, and it is equal to our moles per liter. So if I have a chemical and I have put, let's say 1.8 moles in 1 liter, I know that that is written as 1.8 molar is how that's read. So that's read M-O-L-A-R. Molar is the descriptive term. Okay, so where do we get that? Well, frankly, we'd have to be told what that number is. And so that's going to be in the problem, and it will be written like this 1.8. So we will have 1.8 capital M, and that will give you that molarity that we need. Okay, so what do we do with it? Okay, it is going to be a conversion factor all by itself. Okay, you can take this 1.8 molar and turn it back into this ratio right here, right? The number that's given is how many moles were there, and it's always going to be in 1 liter, because even if we made a solution that wasn't 1 liter, we would have divided that to have gotten exactly how many moles would have meant in 1 liter. So every other conversion factor we've worked with has 1 mole of something is equal to a number of things, because it's always like 1 mole of the chemical equals its molar mass, or 1 mole equals 6.02 times 10 to the 23rd particles, or 1 mole of a gas is equal to 22.4 liters at STP. Well, this time we write it as 1 mole, not 1 mole, the number of moles equals 1 liter. So if I say that we've got, 4.3 molar HCl, that means it's an arrow. It wasn't very good. There we go. Means that I have 4.3 moles of HCl is equal to 1 liter HCl. Okay, so I don't have to change these things entirely. I'm just going to make this be the equality. Okay, and then I can use that as my conversion factor. I can turn that into the fractions, where I can put the 4.3 moles of HCl over 1 liter, or the 1 liter over 4.3 mole, whatever we need to do. Okay. Thing to be careful about is that often when I give you the volumes of it, the volume is what you're going to be your starting value, or the thing we go through, because that's the goal here, is to get this from to and from a volume of a solution. That volume is usually given in milliliters and not liters, and we have to convert that. So that's a very simple conversion, and you don't even have to use the dimensional analysis that we've learned before to do it. You can just simply move the decimal. Okay. Milliliters and liters are exactly the same as going between grams and kilograms, which is really convenient for us, and that is 3 spaces. Remember that you're going to have more milliliters than you are liters, because milliliters are little, liters are big. So if I tell you that we've got 150 milliliters, we need to move that 3 spaces. 150,000 to go 3 spaces this way and call it 15,000 or 150,000 does not make sense, right? We're not going to have 150,000 liters, so we go the other way. Decimals right here, 1, 2, 3, and we end up with 0.15 liters. Watch your significant figure. That 0 wasn't significant until I drew the decimal point in. We scooch it over. Okay, so what can we do with that? Okay, here's our problem. I know that I have 185 milliliters of 1.3 molar magnesium chloride, and I want to know what mass of magnesium chloride that is going to contain. Okay, so we start by taking the 185 milliliters and we turn it into liters, right? So we go again, 1, 2, 3, 0.185 liters. Okay, we're going to draw our line, and that's our starting value. I know we're given two numbers. This molarity, never the starting value. This is always a conversion factor. So we take this and we go 0.185 liters, and we put our happy face down here because it makes us feel good about ourselves. And we're going to draw our line. Okay, we've got liters right here, and I know I need to move liters down to the bottom. Okay, the conversion factor we're working with here, again, is this 1.3 molar, where I can again change that to say 1.3 moles mg Cl2 is equal to 1 liter. So I'm going to say, whoops, shame on me, this here, and Cl2. So I have 1 liter of this is equal to 1.3 moles of that. Well, now I've got it in moles, okay, and now it's an old conversion. We take our moles isn't what I was asked for. I was asked for mass. We bring that down to moles, mg, Cl2 to grams, mgCl2, and just like molar mass, we still want this 1 mole and so many grams. I'll be honest, I didn't bring a calculator over when I went to do this, so we're gonna wing it. 2 chlorines should be about 71, and a magnesium is what, 24.3-ish, so that's, 3, 5, 9. It was a 95.3. And then we take this, multiply across, divide by the bottom, so 0.185 times 1.3 times 95.3, and again, I don't know what that is, so you're just gonna have to guess, figure that out yourself. Okay, grams mgCl2, and it really is no different than any other conversion factor, except the number goes to the moles, okay, and a 1 with the liters, and then we got it.